Hello! In this video, we're going to prove the following theorem. Let a, b, and c be real numbers. If c plus a is equal to c plus b, then a is equal to b. Now in this series, we are looking at a list of axioms for the complex numbers. And these axioms come from MetaMath, and I'll leave some information about it, and including the axioms, in the description below. Okay, so let's first remind ourselves how our system works. We are given a set C called the set of complex numbers. We're given a subset of the complex numbers R called the set of real numbers. And we're given three elements of the complex numbers: 0, 1, and I. We're also given two binary operations on the complex numbers: addition and multiplication. So that means given any two complex numbers, a and b, a plus b is a complex number, and a times b is a complex number. And also, we are given a relation on the real numbers called the less than relation. So, given any two real numbers, a and b, it might be the case that a is less than b. And we would write it like this. Otherwise, we would say a is not less than b. And from here, we have a list of axioms. Right? And the list of axioms is in the description below. Now, to prove this theorem, we're going to be using the following axioms. We have axiom 1, which tells us for all real numbers a and b, a plus b is a real number. We have axiom 13, which tells us for all real numbers a and b, a is less than b if and only if a is not equal to b and b is not less than a. And axiom 15, which tells us for all real numbers a, b, and c, if a is less than b, then c plus a is less than c plus b. Okay, so now let's get into proving this theorem. Now, to prove this theorem, we're actually going to prove the contrapositive of this statement, which means we're going to prove if a is not equal to b, then c plus a is not equal to c plus b. So to prove that, let's suppose a is not equal to b. From here, we are going to show that c plus a is not equal to c plus b. And to show that, we're going to split this up into two cases. Either b is less than a, or b is not less than a. And in either case, we're going to show that c plus a is not equal to c plus b. So let's start with the case where b is less than a. Well, applying axiom 15, since b is less than a, it follows that c plus b is less than c plus a. But then, we know by axiom 1 the sum of any two real numbers is a real number. So c plus b and c plus a are real numbers. So we could apply c plus b and c plus a to axiom 13. So since we know c plus b is less than c plus a, that means c plus b is not equal to c plus a, and c plus a is not less than c plus b. So in particular, we know c plus b is not equal to c plus a. Or in other words, we have c plus a not equal to c plus b. And that's it. That's exactly what we wanted to show. So this completes the case where b is less than a. Now let's consider the case where b is not less than a. Well then, since a is not equal to b and b is not less than a, then by axiom 13, we must have that a is less than b. So then we apply axiom 15. Since a is less than b, it follows that c plus a is less than c plus b. But then remember, the sum of any two real numbers is a real number. So c plus a and c plus b are real numbers. So then, applying c plus a and c plus b to axiom 13, since c plus a is less than c plus b, well, that tells us c plus a is not equal to c plus b, and c plus b is not less than c plus a. So in particular, c plus a is not equal to c plus b. And that's exactly what we wanted to show. So, in either case, we have c plus a is not equal to c plus b. So that's it. We have shown if a is not equal to b, then c plus a is not equal to c plus b. So that proves the contrapositive of this statement. Because the contrapositive is true, that means the statement itself is true. So, this completes the proof. And so yeah, that's pretty much it for this video. Right, we're going to be using this result to prove other results. So this is going to be important. So yeah, that's pretty much it for this video.